Hi there, this is the first example of my Centroid problems here. And what you see is these kind of two boxes, and let's just pretend like maybe someone duct taped them, or let's just say they got welded right here, welded. So that way, you know, they're together, and your boss wants you to find, hey, well, where's the Centroid of this, so we know how to design it. And that'll be your job. So what you have to do is, first up, come up with a reference point. So what I'm going to do is I'm just going to, just for maybe simplicity, I'm going to try and draw these little extension lines to where they're going to intersect, and I'm going to call my reference point. That's how, from this point, this is where all my dimensioning will occur. So let me just do a quick, I mean, it's the same function, it's just a weighted average, right? So x bar, I mean, it's now we just add the sum of the products. So you have a 6-inch difference till right here, so it'll be 3 inches until the centroid of this little box. So it'll only be 3 inches. I'm just going to put 3, forget inches, because that'll all go away. And then, well, I mean, it'll come back. Then times the area. Let's just assume that we can use the area in this. I'm going to assume that it's the same thickness in the back, same density, all these things. So 4 times 6 is 24. So that's our weight. Plus, now we need to find the centroid of this second box, second larger box. So we know that it's going to be, first of all, 6 inches till the start of the box, plus another 6 inches to where the centroid is. So that distance will be 12 inches times the entire area, which will be 120 inches squared, all over the summation of all the area, which will be 24 plus 120, which is 144 inches squared. When you work out that math, it turns out to be 10.5 inches. So we know 10.5 inches, and so we know that it's going to be somewhere in this, along this line, somewhere. We know it's left of the big box's center of gravity, but we know it's within this side of the box because we know that right here is 6 inches. So it's 4 inches, 4.5 inches to the right of the start of the box, essentially. Let's do y prime, the average y, or centroid y coordinate, whatever you want to call it. First off, let's start with this little guy up here. We know that 10 inches right here, minus the 4, we know that you have a 6-inch travel, then plus half of the little box. So that's 2 inches and 6 inches. That's 8 inches total. So 8 times 24 plus the exact the half the height of the big box, which is going to be 5 inches, times 120, all over 144 again. And that'll equal 5.5 inches. So technically, if you were looking at this in real life or whatnot, you would be looking at this something like this. Little object like this, where it would be, 4 inches here, and this distance would be 18 inches, and let's see, what else? This distance would be 10 inches, in this distance right here, 6 inches, and you can kind of see that while the centroid is no longer here or here, but it's actually 4.5 inches over. So from there, so it's going to be somewhere along this line, and then it's going to be 5.5 inches upwards. Well, we knew that this centroid was at 5. The centroid of the large box was at 5, so it's going to be slightly above that. So somewhere like this, so it'll be about there. And that's where our centroid will be. No ruler or anything. I was just giving you a general feel about it. We know the exact coordinates, which would be 10.5, 5.5. That's where the centroid is. And actually, if this whole thing weighed, like, say, 70 pounds or 80 pounds or whatnot, if you consolidated all the forces and you wanted to make them all equal to one force, that's where you would put the force. You would put it right at the centroid, most likely, unless you wanted to put a moment on it or whatnot. But if you're trying to find like an equivalent, this is usually where you'll put it, in the center of gravity. So anyway, let's continue on with another problem.